Sometimes the most meaningful discoveries in brain health aren't flashy or futuristic. They come from ingredients that have been sitting in home kitchens for generations. Resistant starch, found in foods as ordinary as potatoes, rice, oats, lentils, and green bananas, is now emerging as a surprisingly powerful supporter of cognitive resilience. New research suggests that this humble dietary fiber may help guard against cognitive decline by feeding the right gut bacteria and increasing short-chain fatty acids, SCFAs, the signaling molecules that support brain health from the inside out. To appreciate why this finding matters, it helps to understand what resistant starch actually is. Unlike most carbohydrates, resistant starch escapes digestion in the small intestine. Instead, it travels to the colon, where specific gut microbes ferment it into SCFAs, especially butyrate. Butyrate and its companion molecules, acetate and propionate, act like metabolic messengers that influence inflammation, energy production, and even gene expression. These SCFAs are now understood to play a major role in the gut-brain axis, shaping everything from mood to memory. Researchers investigating resistant starch's role in cognitive aging are especially interested in butyrate. This SCFA has profound anti-inflammatory properties, and it strengthens the gut lining, reducing the systemic inflammation that has been closely linked to neurodegenerative diseases. Butyrate also crosses the gut-brain signaling pathway via the vagus nerve and influences the release of BDNF, brain-derived neurotrophic factor, a key molecule involved in learning, neuroplasticity, and long-term memory formation. When older adults have more butyrate-producing bacteria, their brains tend to function more efficiently, with clearer thinking and greater resilience to age-related decline. Several early studies show that adding resistant starch to the diet can meaningfully increase butyrate levels in just a few weeks. Participants experienced improvements in metabolic markers, reduced inflammatory signaling, and even modest enhancements in cognitive test performance. While these gains were subtle, they were consistent, and they point to a powerful truth. By nourishing gut bacteria, people may create a more supportive internal environment for the brain. One reason resistant starch is so promising is its practicality. It's not a niche supplement or an expensive intervention. It is a simple component of everyday foods. Cooked in cooled potatoes, reheated rice, overnight oats, legumes, barley, and even certain breads naturally contain it. Many people already consume small amounts without even trying. What the research suggests is that deliberately including more resistant starch may amplify SCFA production and strengthen the gut-brain connection in meaningful ways. Another positive outcome of resistant starch intake is its effect on metabolic health. SCFAs help regulate glucose control and insulin sensitivity. Because brain energy metabolism becomes less efficient with age, maintaining stable blood sugar is crucial for preventing cognitive dips. Older adults in resistant starch trials often report more consistent energy, better digestion, and improved sleep, all factors that indirectly support brain function. Even more intriguing is the potential for resistant starch to help maintain microbial diversity. As people get older, the microbiome naturally becomes less varied, which weakens its resilience. Resistant starch has been shown to enrich beneficial strains like Bifidobacterium, Roseburia, and Faecalibacterium, bacteria strongly linked to healthier aging and better memory outcomes. Researchers now understand that cognitive decline is not simply a matter of neurons wearing out. It's tied closely to the ecosystem of the gut. Supporting that ecosystem may give the brain extra protection. The emerging science also hints at synergy. Resistant starch works even better when paired with fermented foods, polyphenol-rich fruits, and regular exercise, all of which encourage the growth of SCFA-producing bacteria. This suggests that a simple dietary shift, combined with healthy lifestyle habits, could build a strong metabolic and microbial foundation for long-term cognitive health. What makes this research so uplifting is its accessibility. Resistant starch doesn't require new habits, new gadgets, or specialized diets. It's woven into ordinary meals, familiar to every culture, and easy to integrate. A serving of cooled potatoes at dinner, a bowl of lentils, or a container of overnight oats isn't just a comfort food. It becomes a small act of brain care. While more long-term research is needed, the direction of early findings is extremely promising. By increasing short-chain fatty acids that nurture neuroplasticity and reduce inflammation, resistant starch may offer a gentle, natural avenue for helping people stay mentally sharp as they age. And perhaps that is the most encouraging insight of all. Sometimes the path to a healthier brain begins not in high-tech labs but in the pantry, with ingredients that have been sustaining human beings for centuries.